Hello everyone, welcome to yet another video on our channel Euclid Mathematics. In my previous videos, I explained to you all complementary function and nth order differential equation. So in my today's video, we are going to understand synthetic division for finding the roots of our polynomial equations. Okay, polynomial or equations. Now see that for finding the roots for quadratic, it is quite easier. Some are the polynomial or equation that we can find the root very easily using some standard result, but most of the condition it's quite difficult to get the roots for polynomial or equation. So in such a case we mostly use synthetic division. Okay, so let's get started our today's lecture. I will explain to you all some of the rules for synthetic division, and then at the end we go for some of the example. So that is very much useful here for finding the root and a solution for differential equation. Okay, now see that synthetic division, first rule for synthetic division, it says that when we have sum of all coefficient for our polynomial, okay, consider that we have polynomial as f of d which is equal to 0. Okay, we have polynomial as f of d which is equal to 0. Okay, so consider any polynomial f of d, that means polynomial is in the form of d. Okay, so let me consider one polynomial here, d cube minus 7d minus 6 which is equal to 0. So I do have this polynomial here with me. Okay, so I want the factors. I want the factors for this polynomial using synthetic division. Okay, just I will explain to you all first of all the rules. Okay, and at the end we go for the example. This one is not your example, just need to understand how the rules of synthetic divisions are working. Okay, yes, so I consider here one of the polynomial which is a d cube minus 70 minus 6 which is equal to 0. Okay, so first rule for synthetic division, it says that sum of all coefficient of our polynomial. Okay, that means sum of all coefficient or sum of alternate coefficient. Okay, so let me write here first rule, sum of alternate coefficient, okay, sum of alternate coefficient in our polynomial in f of d, okay, in f of d, okay, are equal to, okay, that means all sum are equal to 0. Okay, sum of f of d which is equal to 0, that means sum of all alternate coefficient of polynomial f of d which is equal to 0 are equal. Okay, that means let's see how the rule it is working. Okay, and now see that as we have third power of a differential equation, d cube means it's a third order differential equation. Okay, so we have to complete entire differentiation, that means third power after second power after first power and then last at the end of the constant. Okay, so how we write this one, d cube minus, so we can d cube plus 0 times d square. Okay, 0 times d square means the term obviously which is absent, plus 0 times, now see that 0 times d square, now 1th power, so first power we already have here minus 70. Okay, so we'll take this one as a minus times 7d. Okay, d cube minus 0 times d square minus 7 times d minus constant which is 6 which is equal to 0. Now see that I converted this auxiliary equation in the perfect form of their powers. Okay, so we can see that here third power, second power, first power, and the d to the power 0, 0th power, that means this one is the third degree polynomial in the form of a d. Okay, now see that what our rule says, that sum of alternate coefficient means the coefficient for d cube. What we have the coefficient for d cube, it is a coefficient, let me explain. Okay, coefficient of a d cube, so coefficient of a d cube which is here 1, coefficient of a d square, okay, coefficient of a d square which is a 0, and coefficient of a d, okay, here coefficient of a d which is equal to minus 7, and at the end we have constant minus 6. Okay, at the end we have constant minus 6. Now see that what we have here, sum of alternate coefficient in f of d. Okay, so alternate coefficient means first coefficient, then third coefficient, second coefficient, and then last coefficient. Okay, now see that, so what is the first coefficient, 1 here, Okay, what is the first coefficient, which is 1. Then third coefficient plus minus of 7, okay, which is equal to, what is the second coefficient, which is a 0. And at the end, what we have, coefficient plus minus of 6. Now see that sum of alternate coefficient. What I am doing here, I am writing the sum of the alternate coefficient. Okay, so first one it is here, and third one here, second one, and that fourth one here. Okay, so check out that sum are equal or not. Okay, sums equal or not. Okay, 1 minus 7 we write minus 6, and 0 minus 6, which is a minus 6. Now see that the sum of alternate coefficient, it gives the value equal. Okay, and in such a case we write one of the root, d which is equal to minus 1, d which is equal to minus 1 is one of the root. Okay, is one of the root. Okay, is one of the root for our polynomial. Okay, now see that actually this one is not the entire roots. Okay, so as a polynomial we have d cube, that means we have to find out the three different roots. Okay, we have to find out the three roots for our polynomial, as already we have one of the polynomial, one of the root which is present here. That means remaining two roots are remaining, we have here two roots. Okay, so for finding remaining two roots, we use the synthetic division. Okay, we use the synthetic division just to get the remaining two roots. Okay, so that is the first rule. It says that when we have sum of alternate coefficient of polynomials, okay, or equation which is a 0, then we write d as a minus 1. Okay, d as a minus is one of the root. Okay, now second rule, we have only the three rules. Okay, let me write the second rule. If constant term is absent in f of d which is equal to 0, okay, if constant term absent, okay, absent in f of d which is equal to 0, so that means we don't have constant term which is in our polynomial or equation. Okay, for example, let me take that previous example, d cube minus 7d minus 6. Okay, so d cube minus 7d which is equal to 0. Okay, so now see that we don't have constant term which is present here. Okay, constant term means minus 6. I didn't take minus 6 here right now. Okay, so that means we don't have minus 6 which present or constant term present in our auxiliary equation. Then we write obviously d which is equal to 0 as one of the root. Okay, we write d is equal to 0 as one of the root. So how it works, now see that we can take d common from here, remaining term we write d square minus 7 which is equal to 0. Now obviously we can see that here d into d square minus 7, multiplication of a two term goes to 0. That means obviously one of term need to be 0 here, d square minus 7 which is equal to 0. So here we can see it is obvious that d which is equal to 0 as the one of the root for our polynomial. Okay, so as we have one of the root which present here, so remaining for finding the two roots, it is easier using synthetic division. Okay, yes, let's go for the third rule. Okay, so what is the third rule of our synthetic division? It says that if sum of all coefficient of f of d which is equal to 0. Okay, if sum of all coefficient of f of d which is equal to 0. Okay, sum of all coefficient of f of d which is equal to 0. That means whenever we add all the coefficient from our auxiliary equation, we get the answer as a 0. Then we write this implies d which is equal to 1 is one of the root, is one of the root. Okay, is one of the root for our differential or our auxiliary equation. Let me explain with one of the example. So here is the example. Consider any example that sum of all coefficient gives us the value 0. Okay, I consider here 2d cube minus d square minus 1 which is equal to 0. Now see that as we can see here 2d cube minus d square minus 1 which is equal to 0. So now add all their coefficient. So first coefficient for d cube which is a 2, second coefficient for d square which is a minus 1, and third coefficient for d to the power 0, that means last constant coefficient which is 1 minus 1. Okay, Now let's go for adding all the coefficient. So 2 plus minus 1 plus minus 1. Okay, so find out their sum. So 2 minus 1 minus 1. That means 2 minus 2, which is equal to 0. Now see that we got the sum for all of these coefficient which equal to 0. Then obviously d which is equal to 1 is one of the root. Okay, it is one of the root. Now what about for remaining two roots? So I will explain these roots in the form of example, and then we go for finding the complementary function for our given linear differential equation. So that one is very much important for you all guys, that you how to solve these examples in your university exams. Okay, so let's go for the next part where I'm going to explain complete example. Okay, first of all we have to find out one of the root from our differential equation or auxiliary equation, and at the end we are going to find out the roots for our quadratic equation or quadratic auxiliary equation. Okay, let's dive into some into the sum of examples. Let's see how it is working. So here we are going to find out complementary function directly. Okay, complementary function. First of all, we apply synthetic division for finding the roots for our linear differential equation, and at the end we go for finding directly the complementary function. Okay, so here let me write the example. Find CF. Okay, CF shortly write we as a complementary function. Find CF. So this one is important question you will get in your SPPU question paper. So, okay, so you need to understand this question properly. It is one of the easier question that gives us a very easy mark. Okay, so here let me consider one of the examples. So d cube minus 7d minus 6, which is equal to 0. Already I explained here in my previous part. Okay, same, I taken same example just for your better understanding. And now see that first of all complete our differential equation in the form of their powers. Okay, so we need all the power which present in our differential equation. Okay, so how can we complete this one? So d cube minus d cube plus 0 times d square. Okay, that means d square term which is absent here, so we write d square as 0 times d square, minus 7 times d minus 6, which is equal to 0. So this one is a complete form of our differential equation or auxiliary equation. Okay, and now see that as per the synthetic division, so we have the rule. What we have rule? If sum of alternate coefficient of f of d, if it is equal, then we write d which is equal to minus 1, which is one of the root here. Okay, now see that sum of alternate coefficient. Now you have to check, we don't know sum of alternate coefficient or if any other rule applicable here. Okay, sum of all coefficient or any other rule it is applicable here. So for sum of alternate coefficient, okay, let's go for sum of alternate coefficient. Now see that sum of first coefficient d cube coefficient, which is a 1, plus its alternate coefficient minus 7, and again for second coefficient 0 plus its alternate coefficient, which is a minus 6. Okay, so first coefficient here alternate it is here, second coefficient here its alternate it is here. Okay, add their coefficient 1 minus 7, which is a minus 6, which is equal to 0 minus 6, which is equal to minus 6. Okay, now here we can see we have alternate coefficient sum which is equal. Then obviously we have here d as a minus 1. Okay, d which is equal to minus 1, d which is equal to minus 1, which is one of the root, which is one of the root. Okay, which is one of the root for our auxiliary equation. Okay, now our next target is that for finding the another remaining two roots. Okay, as we have cubic auxiliary equation we have here. So if it is equation is in the form of a cube, obviously that means we get the three roots. Okay, m1, m2 and m3. These three roots are coming from our auxiliary equation. Okay, so our target is that to find out remaining two roots. Now see very carefully here. Now we are going to apply synthetic division just to find out the remaining two roots. Okay, yes, now see we have one of the root here, d which is equal to minus 1. Write down minus 1 as it is here. Okay, just we have to make the its structure first. Okay, So this one is the form of a synthetic division. We write this structure in this form. Okay, so minus 1, this one is the first root. Okay, d is the minus 1 is the first root from our given auxiliary equation. Now remaining we have to find out here the values here. Okay, what are these values? These values coming from the coefficient for our auxiliary equation. Now see that what are the coefficient? 1, 0, minus 7 and minus 6. Okay, 1, 0, minus 7 and minus 6. These all are the coefficient from our auxiliary equation. Okay, now what we do, so let's go for applying synthetic division. So as we don't have anything coefficient here, take 1 as it is downside. So I'm taking that 1 as it is down here. Okay, yes. Now what we do in next? So multiply these two numbers, minus 1 into 1. Multiply minus 1 into 1, we get the minus 1 here. Okay, and write down this one is here. Okay, this one into this, minus 1 multiplied by 1, write down here as a minus 1. Okay, I'm repeating again, this one is very crucial step. Okay, now next step, what we do? We add both of them. So what we do? We add 0 plus minus 1. Add these two numbers, 0 plus minus 1, which is a minus 1. Okay, repeat similar process as we have done earlier. Okay, so multiply these two numbers, minus 1 into minus 1, which is the plus 1. Okay, whenever two negative numbers multiplied, which gives us the positive number. Okay, so minus 1 plus, again add both of these numbers, minus 1, 7 plus 1, which is a minus 6. Again multiply these two numbers, minus 1 into minus 6, which is a plus 6. So it is plus 6 here. Okay, minus 1 into minus 6, which is a plus 6. So now go for the addition of remaining two number, minus 6 plus 6, which is a 0. And always remember guys, we want the 0 here. So if your 0 not coming here, that means you done some mistakes before in our solution. So make sure that try to get the 0 here. Okay, if your 0 not coming, then go for again that solution. Okay, and now see that so this one is the required solution. We have to find out the root. Now we know that synthetic division, it is a method which is applicable for finding roots for our nth power. We can take it square, cube, anything. Okay, but it is used to convert that cubic equation into square or sixth power equation into square form. Okay, yes. Now what we do? Compare this one with their constant coefficient. So 1 we multiply with a d square, second it goes to d to the power 1, and last it goes to the d to the power 0. D to the power 0 means 1. Okay, yes. So how we get the quadratic equation? So it is basically convert that cubic equation, this cubic equation, into the quadratic equation. Now see that our quadratic equation, d square minus d minus 6, which is equal to 0. Okay, d square minus d minus 6. So d square into 1, d square, d into minus 1, minus d, and d to the power 0, 1. Okay, 1 into minus 6 is minus 6, which is equal to 0. Now see that we converted our cubic, this one is our cubic equation. Okay, we converted that cubic equation into this quadratic equation. Okay, so find out the two roots from our quadratic equation. So we'll get the roots as, now see that if you are not able to find out the straightforward root, I'm telling you guys, apply directly the standard formula for finding the quadratic roots. So how can we find the quadratic root? So whenever we have the quadratic equation, ax square plus bx plus c, which is equal to 0, then we write the root as minus b plus minus square root of b square minus 4ac upon twice of a. Okay, this one is the standard result that gives us the quick answer and accurate. Okay, so we want the precise answer here for the solution. So make sure that go for finding the precise solution. Okay, so apply. So what we get here, a is the coefficient of d square, b is the coefficient of minus d, and b is the coefficient of d, and c is the coefficient of here. Okay, so the value for a1, b which is a minus 1, and c which is a minus 6. Replace all these values here. Okay, you will get the given roots. Okay, so or you can find out directly, find the two numbers, their multiplication is a minus 6 and there is a addition is a minus d. Okay, so you can get these two numbers as minus 3 and 2. Okay, so you can take minus 3 into 2. Okay, minus 3 into 2, minus 6. So minus 3d minus 2d. Okay, minus 3d plus 2d, which is a minus d. Okay, so we write d square minus 3d. Okay, d square minus 3d minus plus d. Okay, plus 2d. Okay, d square minus 3d plus 2d minus 6, which is equal to 0. What I have done, I written minus d in the form of minus 3d plus 2d. Okay, so 2d minus 3d, which is a minus d. Take d common from here, d minus 3 plus again 2 common from here, d minus 3, which is equal to 0. So d minus 3, again take it common. Again we remain here with the d plus 2, which is equal to 0. So what are the values for d here? D which is equal to 3 and d which is equal to minus 2. These two are the separate roots for our quadratic equation. But as we have cubic equation, we don't have quadratic equation. We are working for third order differential equation. So already we have got the one d as a minus 1. D as a minus 1 is the first root for our auxiliary equation. Okay, d as a minus 1, d is a 3 and d as a minus 2. These are the three different root. Okay, they are not equal. Okay, these are the three different root. So we are going to find out the solution for three different roots. Okay, so we know that whenever we have three different root, we write complementary function or y of x as a c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x. Okay, so that we have m1, m2, m3 are the three roots. So reply minus 1, 3 and minus 2 here in the value of m1, m2, m3. So d means this one is m1, this one is m2, this one is m3. Okay, it is not that necessary you consider m1 as minus 1. So you can consider m1 as minus 2 or m2 as a 3. Okay, so just replace m1, m2, m3 here. So we'll get the complementary function as c1 e to the power minus x plus c2 e to the power 3x plus c3 e to the power minus 2x. Okay, this one is our required complementary function. Okay, required complementary function for our linear differential equation. So this one is our entire solution. If you want to see, guys, you can go for my entire solution here. Okay, this was using synthetic division. I found these three roots, and after getting these three roots, I replace the value in our standard solution. This one is only the complementary function, not a complete or general solution for our differential equation. Okay, so which we have to find out the particular integral for this. Okay, so that one is for our synthetic division using complementary that one is our complementary function using synthetic division. Okay, I explained here only a single rule whenever alternate coefficient sum is equal. Okay, so you can apply same method for whenever the constant term absent, that means d is equal to 0, which is the term there. Okay, then we write one of the root as a d is equal to 0, one of the root there. Okay, if constant term absent, or if alternate coefficient sum are equal, then we write d as a minus 1 is one of the root. Okay, so that's it for our today's lecture. So it is already lengthy lecture. I don't want it to take it this much, but for your better understanding, I took this lecture little far. I hope you all have understood this lecture. Even after, if you found anything difficult, anything related to this, let me know in my comment section. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.